Hello and welcome to today's webinar, Simultaneous Scaling for User and Application Growth. In the next hour, we will discuss the best ways for you to accelerate your journey to cloud native with Kubernetes and open hardware. Our speaker today is Eric Rydell. He's the Senior Vice President of Compute and Storage Solutions for IT Renew. Eric leads engineering for IT Renew's data center solutions, including the Sesame for Open Systems Kubernetes cluster platform. An active contributor to the Open Compute project, Eric has over 20 years experience designing and building scale-out computing technologies in the cloud storage and open architecture space. Now, before we get started, we encourage you to ask questions using the Q&A feature. Simply click on the Q&A button at the bottom of your screen, and then type in your question for our speaker or panelists on the right-hand side of the webinar browser. You can ask questions at any time, and there will be a Q&A session at the end of the presentation. Now, this webinar is being recorded. Both the recording and Eric Rydell's presentation will be made available to you following this broadcast. So let's kick off with a question. Eric, we hear a lot about how many organizations are on a journey, so to speak, to build scalable platforms in the cloud. But can these organizations really afford to take 5 to 10 years to ramp up their cloud native initiatives?
Thanks for that question. It's really the premise of our presentation today is that there's a number of factors that are outlined and changes in the ecosystem that are really accelerating this journey. Some companies have been on this journey for an extended amount of time, but it's certainly accelerating for some, and that's what we're trying to motivate here. So let me get into the details here. So I'm going to talk about two-dimensional scaling. So scaling user growth and application growth. And I'm going to talk about the application of open technology, open hardware, open software to those initiatives. Thanks so much for taking time from your day. I realize there's a lot of competing, items competing for your attention, a lot of things going on in the world. So appreciate everyone spending some time with us today. So very briefly, the background. So I'm with IT Renew, based out of Silicon Valley in California. We have several lines of business. I'm with the Sesame by IT Renew division, building rack scale solutions. That's what I'm going to talk about today. There are other parts of the business working in edge solutions, and we've been working on rack solutions, server solutions, and data center activities with all of the largest service providers for almost the last 20 years. So we have relationships with many of the largest companies, Silicon Valley and worldwide, including Microsoft, Google, Facebook, Dropbox, Uber, et cetera, some of the logos mentioned here. And we're trying to help a wider audience bring that same technology that is successful for those service providers to a larger set of audiences and companies. So this is the abstract, the email that brought you here. So I want to talk about this two-dimensional scaling and of users on one hand, and additional applications, new applications on the other hand, both of which increases the demand for technology in your enterprise or in the enterprises that you work with. And as motivated by that introduction, the journey to cloud native has been discussed for some amount of time, but there's numerous pressures to increase that. And so we're hoping to provide some motivation for how companies and customers can overcome those barriers and effectively do this scaling. And the core premise is going to be the use of open technology and open for all. And this is really what I hope to bring home in the next 40 minutes is the detail of how this is real today. Open is real and available, accessible today. It's no longer something that we discuss. Someday we'll be able to take advantage. It's something that everyone can take advantage of today. So let's get into it. This is a picture of maybe your planned journey to the cloud, or if you're a service provider, the journey that you're trying to bring your customers on. I've been involved in cloud technology for basically my entire career. 18 and 20 years ago, we didn't know to call it cloud or even open technology, but we were already collaborating together to build large-scale infrastructure, and that's now become the lived reality for many. And so, how do we make it practically accessible? So here's your planned journey to the cloud. So maybe a nice straight path. There's some shadow and shade along the way. Maybe there's some mileposts, but it looked nice and steady. Or maybe alternatively, you had a different set of decisions. You're building on some existing infrastructure, adding to an existing infrastructure, but still nice straight paths. Maybe some increases in the pathways, but a clear path leading to the cloud. You had a plan. You had a compass. You were doing prototype applications, beginning to use some of the technologies that I'll talk about: Kubernetes, CI/CD, agile programming, etc. And most importantly, it seemed like you had time to get there. All right. And not just to recognize, as I said, I've been doing this for a long period of time. I've talked to hundreds of IT organizations in various stages of this cloud journey. And so it's by no means always a straight road. Maybe there are bends in the road and there's fog on your way to the clouds. Maybe you're building on existing infrastructure and you find that there's some decay, there's some moss adjacent to your railway tracks. Maybe your maps are a little old. The technology is constantly refreshing. It seems like there's a new set of acronyms this month versus last month, this year versus last year. And maybe, just maybe, you're operating as on the photo on the right, where you're barely balancing your transition to the cloud among all the existing kind of dangers and technology. But most importantly, importantly, you felt like you had time. You felt like it's something you could take incremental progress toward. Like I said, start some prototypes, get some feedback, get some user success, experiment with the new technologies and the new way of delivering technologies, but do it incrementally upgrade, incrementally transform your business to this new way of operating. Right? There was some time available, but suddenly there's a new set of pressures, right? That we've all seen, and maybe they've, in your world or in the world of your customers, they've turned this picture upside down, where suddenly there's time is moving faster, or there's not as much sand available in the hourglass as it looked like even 3 or 6 months ago, right? Why is that? There's certainly many trends driving technology. The most recent ones, as we've all shifted the ways we work, have put increasing strain onto the IT infrastructure, right? These are some photos of the new ways of work, right? I picked these photos because there is various times of day, sort of brightness, darkness. There's various beverages now being consumed while you work. So maybe coffee in the morning, maybe water with an apple for lunch, maybe wine with your evening computing. There's a wider range of demands being put on the IT infrastructure with this changing in the way that everybody's working, and this is true in our own lives. If we think about how the pressure that you yourself are putting on the IT infrastructure that you use every day, in addition to the wider world, right? Billions of people adjusting their habits in ways that often reflect on the IT infrastructure. And so what does this really mean? Bringing it back to kind of the 2 dimensions. So the 2 dimensions that we want to explore in this talk is on the one hand, the increase in user growth on existing platforms, on existing applications. So there are more users on the platforms. They are using the platform at additional hours, longer hours in some cases. In wider geographies, it's suddenly much more important for every enterprise to reach all their customers through digital and online means. Maybe in the past, customer penetration for online access was 20 or 30%, maybe in a healthcare setting, and now it's 70 and 80% from 1 month to the next. Right. So there is user growth in existing applications. That's the first dimension. Then the second dimension, shown on the right, is the increase in the number of applications. So the applications for bringing photos into presentations, for watching videos, for interacting with streets and maps, interacting with healthcare, as I've said. So a wider range of applications, the type of applications and the functionality of those applications is increasing. And that's also putting a pressure on the IT infrastructure. All right. And the way that that we characterize it in the experience with some of our customers, and the way that that we've navigated this kind of day to day, is the open software community is incredibly powerful and incredibly rich these days in assisting companies in bringing up new applications. There are frameworks, application frameworks for every type of user interface, for every type of data processing, data management application, every type of machine learning, et cetera. Remote health facilitation. So there are frameworks available now that, compared to 5 years ago or even 2 years ago, would have required a small army of engineers and developers to put together all the pieces of, for example, a remote healthcare application, where today, combining a set of open source frameworks, a set of powerful user interface frameworks or data processing frameworks, machine learning frameworks, video processing frameworks, this is all very straightforward to do. That's the power of the open software and the collaborative software community has made development of new applications and new IT functionalities much easier, right? And that still leaves the situation on the left, the user growth. And at the end of the day, the user growth must, one way or another, manifest itself in increases in the physical plant, right? So there's obviously also some benefits to software optimization, more efficient algorithms, et cetera. It's always progress in using computing more effectively. But at the end of the day, if your application is going to support 100,000 users rather than 5,000 users, it's going to require more IT equipment, more infrastructure, not just more lines of code that are written on the software side. So this is the essence of the two dimensions that we want to talk about in this presentation. And so the good news for many of us, or certainly for the largest cloud service providers, is that the cloud service providers are already ready for this effect, right? We read a story that Microsoft spun up a new data center in less than a week in response to the sudden massive increase in traffic on their Azure platforms and Office platforms online, right? And the reason that the largest cloud companies can do this is because they already had the physical plant. They have the hardware deployed, they have the systems, they have the data centers in place. They've been making these investments for a number of years, specifically with the goals of being able to meet this elastic upside in demands. So the cloud providers are ready, and they have stepped up to this. As I said, IT Renew, we've been doing business with these cloud companies for 10 and 15 years in some cases. And so we experience this with them. We're well aware of these growths and the investments that they've been making, right? Very large pools of money, pools of talent to optimize and deploy all this technology, right? Most advanced technology, flexibility to move technology between applications, between users, even between geographies necessary, and some of the lowest operating costs in the business. If we think about PUE in data centers, or the efficiency that I talked about, a more efficient algorithm versus a less efficient algorithm could save you sometimes half the computing, right? If you have a more efficient algorithm, you can do something with 1,000 servers that previously might have taken 2,000 or 3,000 servers. So there is absolutely lower costs achievable, unit costs achievable with some of these investments. So this is how the largest companies do it. What about your customers or your own businesses, right? So what if you had the advantages of the hyperscale cloud service providers in the efficiency of your infrastructure deployment, right? So you could deliver more services, as I said, applications, grow the user base, increase the number of users, respond faster to customer needs, which is basically now just a requirement, a given, right? It's expected that doctors will do telehealth, right? That companies will sell their products online when previously they had a mainly offline presence, right? And this all flows ultimately to the financials one way or the other, right? Okay, so let's peel the curtain back a little bit. We'll look behind the curtain, and as in our experience, so it's not my own experience. As I said, 20 years building cloud. Many of my colleagues are also the same level of experience in different aspects of the cloud business. So we're bringing together a lot of this expertise. And let me explain how we think all of it applies in approaching the things. So I have 5 sections of this consideration, and I'll go around and discuss each one briefly in turn. So the first one is the hardware design, right? So there's a lot of complexity, a lot of rigor in the development and design of advanced computing platforms, whether it's processors or memory or storage devices. A lot of engineering has gone in over the last 10, 15, 20 years to optimize the way that computing and computers operate. That has made them much more capable, has also made them significantly more complicated, right? So there is an investment in rigor and design expertise at the hardware level that has to be cared and managed, right? Investments. And then there's a similar investment, an analogous set of investment in the software world. That we also have software componentry, those open source modules that I talked about for all different types of functionality. They also need a design rigor and an evaluation and of quality controls, reviews, etc. That have to be done at software. It's very analogous to what we do in the hardware world, and the ecosystem requires just as much or more attention to detail now that we're all interdependent, right? So that's hardware and software. But then what we should recognize, even just I've characterized hardware and software, if we now think about the details within all of those spaces, it's a very wide range of expertise and skills that need to be applied to this system design, all the way from capacitors to the cap theorem, right? And additional expertise areas such as cognitive load, user experience, etc. So hardware from capacitors, consensus algorithms. There is complexity all along this wide chain. Often it's isolated. The complexity is isolated in particular areas, but there is interaction, right? So if the capacitor blows, too many capacitors blow in your server, then the server crashes. If too many of your servers crash, then your application won't run. So you have to take those interactions into account, which is why in order to get the most efficient, the most effective solutions, we need all of those expertise at the table, very wide range of skills. Right? The same thing occurs even within my own engineering team. So I have hardware engineers, electrical engineers, mechanical engineers on the team, as well as operating system engineers and engineers that work with Kubernetes orchestration or user experience for our enterprise customers. Right? A very wide dynamic range, and so we have to make sure that the rigor from parts 1 and 2 are taken care of across this entire range. A lot of collaboration, a lot of communication, a lot of learning. Right? Then the next part, over the last 5 years or so, and of the evolution of DevOps and SRE, we used to just call this sysadmin, but this is a discipline that has significantly expanded in recent years and provides this explicit partnership, not just between the folks, hardware engineers, software engineers that design the technology, but also those that operate the technology, right? So it used to be very much the case that we would design in engineering, we would design something and run it through some quality cycles and then make it available to the world, make it available to the deployment staff, the operations staff, and then move on to the next big project. That's no longer effective in the agile world, the responsive world that we live in, and that's where DevOps has stepped up. So this is collaboration between the operators as well as the designers, and this adds to that hardware software, right? So the operators, the need to be just as aware of the capacitors as the CAP theorem when things go wrong, for example, right? And then the final piece of this, the fifth part of the puzzle, if you will, in this diagram, is automation. And this is where there's some good news. If you think that the other 4 items I've made it sound more complicated, more work to do, the good thing is we're doing that work together and collaboratively. So hopefully each individual person doesn't need to work harder, but we're collectively working harder for better approaches. But we're also turning to the machines, right? So in order to orchestrate and effectively manage a hyperscale fleet of hundreds of thousands of nodes, we turn to the machines. And the machines making operational decisions, in some cases helping to make design decisions or leading us in the right direction of designs, but also making operational decisions so that the machines are organizing themselves, are responding to changes in the workload, and up-leveling the interaction that the various humans in the diagram are able to make. Right? So we believe that the open ecosystem kind of underlies all of this, but there is still significant work, hard work, diligent work that needs to be done in all of these areas. And the good news is that the industry and individuals and individual companies are stepping up to this. So let's briefly try to drill in this a little bit, the next level of detail in first the hardware space and then the software space. So here's 5 trends, 5 pillars that we look at when we think about open hardware solutions. For example, our own participation with the Open Compute project since 2011. I was part of the early years in a previous job, heavily involved at this point. And before that, less formal open community efforts. We used to call them standards committees. We've also obviously worked open source. I've been part of the Linux community for over 15 years. There are a lot of open communities in the open hardware space, kind of Open Compute project, but there are wider collaborations, right? But so the important thing that we're trying to achieve by working together across the industry rather than just bilaterally with a small number of vendors, just a supplier providing a solution to an upstream integrator, is that we get more flexibility, right? So we have this multi-vendor approach, we have standardization, so there's modules that are standardized and can be put together in lots of different ways. So certainly we had the technology and the capability 10 years ago to build a certain integrated rack of computers and storage and networking, for example. But today, there is such a wide range of options, and they can be plugged together, connected together, because of this investment that everyone has made in terms of open standards, vendor collaboration. Right? High density computing. So there is investments that give more computing per unit volume. Both in terms of storage, right, hard drives capacity, flash capacity, in terms of servers, capacitors, and gigahertz that can be delivered, IOPS that can be delivered, and networking in terms of latency, bandwidth, number of network links, and so on. Right. So there's definitely an increase in density. Some of the racks that I'll talk about briefly later, our solutions have 40, 50, or 100 nodes in a single rack, interconnected with 25 gig and 100 gig Ethernet, where a few years ago we were talking about a fraction of those performance levels. Right, definitely increased in computing density. Right, optimized power. Right, so once we've dealt with the top end of performance specs, then the question is how many electrons, how much energy are we feeding into these servers and systems for a given unit of work. Right, the Open Compute project has made a lot of investment in rack level power, which gives improved efficiency. There's less power supplies. They're individually more efficient. So you have fewer points of failure, it's more efficient, and it costs less. You have less material, it's individually more efficient, and less parts mean less failure. Right? It's optimized power. Optimized cooling, right? So one of the dirty secrets are no longer so secret of a data center, right? Every electron that goes in as power must be exhausted as heat. The thermodynamics also live in the data center, and then similarly as with power, rack level cooling and row level cooling, hot aisles, cold aisles, data center designs can optimize the cooling infrastructure, right? Which is really reducing an overhead or a drag on the efficiency of the rest of the operation, right? The more of the electrons that are going to the IT workload, the better off it is for everybody. And then finally, streamlined maintenance. And this sounds like it could be just an afterword or an asterisk at the bottom, but this really is critical. And all the largest cloud providers have found this. When operating with 10,000 or 100,000 nodes and millions of customers, millions of applications, tens of millions, hundreds of millions of services and containers and virtual machines, there has to be streamlined maintenance. It can't be the case that individual screwdrivers or individual button clicks are necessary to affect change on 1,000 servers, for example. 1,000 servers have to be updated with a single click, not with 1,000 clicks or something of that order, right? So streamlined maintenance is important at the hardware level, but also at the software level, as I'll motivate on the next slide. So 5 pillars of optimization that we've been able to drive by working together as a community. Right. So next, the benefits of open software, and I've taken a small liberty, but I've made analogies to the exact same 5 areas. Multi-vendor standards for software components. That's what enables rapid deployment, those applications. High density computing with automation, with API-driven scalability, allows more software to run per square inch of silicon because the software is more efficient, more automated than it was. Not just the machines are more efficient, but also the software. So you get a multiplier effect. The software runs twice as fast because of an algorithmic or a design change, and then the hardware is twice as fast because of a silicon density improvement, and suddenly the applications are running 4 times as fast. Right? Optimize power, I've taken a little bit of liberty, so I've used power here in terms of functionality and features. Right? By stacking different software components together, you're able to get a much more effective footprint, set of application features more quickly. Right? Again, cooling, I've changed to validation, but this is super important in the software space. We're using the computers to validate and optimize and test the software before it gets deployed. So we don't notice problems in the field. We notice problems in the continuous integration pipeline, in the test processes before software reaches the field. Ultimately results in less field failures, which are much more costly than design flaws. It's much easier, much cheaper if a design flaw is caught on the floor of the test process or in your CI/CD process than if it's caught in the field. Right? And similarly, the streamlined maintenance, right? Which applies just as much to software as I've already motivated on the hardware side. All right. So here's another kind of collage that hopes to show this this progression. So we've used our more agile methods. We've built the physical plant of our cloud cities and the underlying and a physical infrastructure of the clouds. And that allows us to effectively use the different software stacks, different colors, different flavors, if you will, to build out our IT infrastructure. There's just a very rich menu to choose from, and that allows more application success. This is what it actually looks like on the back end. So I've taken the CNCF landscape for Kubernetes, try to bring this back to a set of practical applications. And even this, though this looks complicated and kind of off-putting on the outset, the important thing is there is specialization in each of these categories. There are multiple vendors, there are APIs and interoperability and modularity across all of these systems. So this should be seen not as bad news, oh my, there's so much to navigate, so much to understand. The standards process and the open software process have made interoperability across these layers and these components and these component features much more accessible than it was. So read this as good news and not bad news. Right? So let's bring it around to the solutions that we're putting together with Sesame by IT Renew. So what we're doing is assembling a set of hardware appliances, so rack level computing, storage, networking appliances, built on the principles of HYPERSCALE and leveraging intensely this open architecture. So without the benefits of open software, none of this would be possible, and without the benefits of open hardware, this would be a much more difficult premise for us to build on. And so we're doing that, a reliable, consistent set of designs, and a business-changing TCO because of some of the models of circularity and sustainability that I mentioned. I'm not going to go into all of the details or much of the details of how we do this, but I want to describe a little bit about these solutions. So what we've initially optimized is for particular application paradigms, right? So the one I'm going to talk about today, Sesame for open systems, designed with that Kubernetes software community in mind, all of those applications in that CNCF landscape. And so what we've done, we've integrated a set of compute nodes in a rack, OCP design, so dense 3 nodes across in 2U, a set of servers, 45 to 48 servers in a rack, rack level switches at the top, and built to the architectural paradigm that matches the orchestration layers of, for example, the Kubernetes framework. We've also done certifications with the VMware virtualization layers, working with various software-defined storage companies to pre-qualify the software against these stacks. So taking advantage of those open systems and those common design patterns to optimize a hardware solution that is ready and purpose-built for bringing in those software solutions. Now I want to talk a little bit about a case study that we've done in the space. I talked about this more extensively in my presentation during the recent OCP Virtual Summit. So this is going to be a microcosm in the resources at the end. You can direct you to the video, the online video of those talks. We also have shorter videos of the various hardware platforms. So I'm not going to discuss those details further. I do want to talk about the solution on the left-hand side. So this is our Sesame Discovery Fast Start appliance. So this is an appliance that we've built that fits under your desk, fits in your basement, in your home office, if you want, in your lab, as a means of making the HYPERSCALE technology accessible. So the nodes in the Discovery are the same nodes as in our rack. And so I'll talk about a case study done against the Discovery. All right. What we're trying to accomplish in this case study is try to bring home the practicalities of what I outlined earlier with open software meets open hardware, right? So we're trying to pre-qualify a set of software stacks so that a customer of ours can take a Sesame rack, offload it from the truck, roll it into the data center, plug it into the wall for power, plug it into the wall for networking, and be up and running within minutes or hours, small digit hours. So deploying new IT infrastructure in a few hours or a few days when what you would have taken weeks and months in the past, right? Of forming a committee and answering questions and talking to IT and interviewing vendors and so on. This is now something where we can take a rack from our loading dock to running applications within ultimately hours, but certainly in small digit days. And that's possible because of the partnership, right? These are fully featured nodes. So the nodes that we're going to talk about are dual socket HYPERSCALE servers. And what we're doing with the software is we're bringing that kind of DevOps automation that I mentioned, or we're bringing DevOps in a layer. So bringing open software to begin with, Linux operating system, in this case Ubuntu, bringing the tools of DevOps, in this case Docker, Ansible, and bringing automation that's tied into frameworks such as Rancher we're using for Kubernetes. And as in the title of my other talk, kind of from servers to serverless in 10 minutes. And we'll motivate some of the steps of doing that. So what we did, we took our a 4-node Discovery appliance, 100 cores, a terabyte of memory, 30 terabytes and 50 terabytes of high density storage. We deploy operating system level against this. So Pixie servers, DHCP, booting processes, remote, validation of all the images that are loaded. So OS deployment, that's one set of features, one set of dashboards, and then getting to actual orchestration deployment. So this is the dashboard as seen from Kubernetes. So we see 48 virtual cores now. There was physical cores in this view, virtual cores in this view. Again, terabyte of memory, just short of 200 virtual cores, 100 physical cores in these 4 nodes. And the worker nodes are ready to accept application workload. Another few minutes. And another few minutes, we can look at this dashboard where workloads can be configured. And this is really what the DevOps operator, what the end customer really cares about. What percentage of my infrastructure system is available for workload today? And we show 1% utilization of the CPU, 2% of the memory, and you can watch these dashboards increase as the workload goes up, right? In fact, that's how we pursued the next level of this case study. So the initial part of our case study was, what is the period of time that it would take to bring up the software stack? We've actually done this test with 3 different Kubernetes stacks. The shortest one was just over 20 minutes for that 4-node cluster. We believe, we've since repeated the study with a rack level, and it's only a few minutes more. So there is parallelization of all the long-lived activities. So we're comfortable that we can bring up a rack of computing to the level of that Kubernetes dashboard within an hour, certainly, and in many cases less than that. All right. So we tested 3 different frameworks. So Rancher, Ksphere, and a Talos infrastructure. And then we tried to do a modest set of performance benchmarking. So this is really micro benchmarks, if you will. So we saw how many pods could we deploy with the sleep container. So a sleep container basically does nothing, just as it says. Container starts up and goes to sleep. So we showed that we could do up to 3,000 pods, so 3,000 containers on a single node. So that means 12,000 sleep containers on our discovery. And then when we try to do a modestly more interesting workload, so an Nginx, a small web server, we can do across all 3 frameworks 500 pods before we begin to notice kind of instability in the system. So all 3 frameworks were able to bring 500 Nginx pods. Again, this is a micro benchmark. And as the note says, in order to do this benchmarking, we actually had to relax the built-in Kubernetes limits. So normally Kubernetes only allows 110 pods to run on a single node. So think about that, 100 applications or 100 microservices within an application. We were able to push it to 500. So shows that the scalability is there to accomplish as designed. So not only can we bring the software infrastructure up quickly, but it's scalable once we get it there. So the result of this case study, we didn't quite hit our 10-minute target, but within 23 minutes for a 4-node cluster, and only slightly longer for a 40-node cluster. Right? So the simplicity of the infrastructure, the scalability of the infrastructure is there, both at the hardware software layer. So we can really represent to our customers that we really can roll in a rack, proven technology, and be up and running. So servers to serverless within an hour, certainly within 1 or 2 days from the time that you place an order to when you can be running workload. And that's all possible because of the investments that have been made across this community. So this is not some immediate, massive innovation that we did with the team at IT Renew. We're building on many, many years of open innovation. Right? So those are our kind of rack scale solutions. Finishing up with kind of a call to action from here. So if you're interested in more information, the first link goes through to our resources page, the webinar Uncomplicated. So there's a set of IT Renew resources. We have a channel on YouTube where you can watch, see links to some of our older talks, but also for those that are interested in the hardware, kind of visuals of the hardware and more details than what I showed in the chart. Reach out to me. So this is my Twitter profile, Rydell at Work. The QR code leads to our Sesame engineering GitHub. So please reach out to us, collaborate with us. We're always looking for additional collaborators. We're very involved across the community.
So Eric, thank you very much for sharing this great presentation and sharing your insights about scaling for both user and application growth with Kubernetes and open hardware. So we're going to switch now to the question and answer portion of the webinar. And if you'd like to ask a question, simply click on the Q&A button at the bottom of your screen, then type your question on the right-hand side of the webinar browser. And let's get started with this question. Eric, are you saying that the transformation needs to happen all at once? In other words, do organizations need to upend all their hardware infrastructure and start from scratch?
Yeah, absolutely not. What I tried to motivate was the increasing set of pressures, whether it's the changes due to pandemic response, changes due to the way that business is transforming, that there is more pressure than there ever was on a speed of transformation. But it's absolutely not necessary to do wholesale change. So one doesn't have to clear everything out of the data center and start new. This can be done incrementally over a financial cycle or over an upgrade cycle. And we see that with many of our customers. So many of our customers saying, hey, for our new applications, we're developing cloud native, we're using Kubernetes, we're using a fleet that is a private cloud, essentially, and we continue to have kind of purpose-built applications, but more and more of the footprint is becoming end-to-end integrated, kind of cloud-native, private cloud, if you will.
So when this crisis is over, do you really believe that we will need all of this hardware infrastructure that we've built up? I mean, times could change. Would all of that go to waste?
Yeah, absolutely. Times will change, as quickly as the new ways of doing things have come. Some of those pressures will reduce, but the history of the IT industry is that no one ever goes backwards, right? And take for example the motivating example that I've mentioned a couple of times of telehealth, right? So it seems impossible to me once customers have gotten used to speaking to the doctor at a chosen time through a video interaction, that customers will want to go back, or consumers will want to go back to sitting in waiting rooms and having months before appointments, because we're trying to all navigate a narrow kind of physical space and a calendar. So the history of IT is that the number of applications and the richness of applications only increases. And that's what we also see in our customer base. So I wouldn't expect significant backwards pressure in terms of utilization. Customers and companies will simply find other ways to use the computing. And by having open, flexible architectures, they can move between applications with ease.
Okay. Is building applications really as simple as downloading open source? Isn't it more complicated than that?
Yes. Yeah. Absolutely. Absolutely. I purposely tried a bit with my graphics and tongue in cheek to mention this as hey, pull off a couple of frameworks from the web and plug it together. But I mentioned in that central part with the 5 areas, there is still a level of diligence and design and engineering that has to be applied even when using open source components. And the same is true within the hardware space, right? That's why we have to have an engineering team at IT Renew in order to do the care and diligence of bringing components together and making sure that in practice, when our racks are delivered to customers, that it functions as designed at delivery time, and 2 years, 3 years, 5 years later during the operational period of those systems. So absolutely, the investments are ongoing.
Okay, so what about proprietary software? Does the open hardware you talk about just apply to open source software, or can I use it with proprietary?
Sure. Absolutely. The trends, the good news is that the trends in hardware improvement are available to proprietary internally developed software, just as they are to software that is built in collaboration with others. It's simply my lived experience, as well as many of my colleagues in the community, that operating in the open and leveraging each other's work freely still leaves enough work for everyone to do. We can simply focus on the next level of technology, the next level of feature improvement, rather than in independent silos reinventing the same wheels over and over again. But yes, there is absolutely no requirement that in order to use Sesame hardware, it must be open source software. But building on all of this ecosystem is a leverage point for everyone.
All right, if we go back to your case study, why is the time to deployment so important? Does time really matter?
Yeah, absolutely. So we use that as a way to cleanly identify the end result, right? That the time to solution is critically important. Now, in booting the machines and installing Kubernetes, is it critically important that it be 10 minutes instead of 23 minutes? Or for a row of racks, for 1,000 racks, is it important that that be done in 3 or 4 hours versus in 3 or 4 days? It's probably not critical. Maybe that first order of magnitude maybe isn't as critical, right? But beyond that, it certainly is. So it cannot be the case that in order to deploy 100,000 servers, it takes 1,000 times as long as deploying 100 servers. Right, the exponential growth in a lot of those numbers simply wouldn't make sense. So while an individual optimization might not be critical, the combined end result is, and that's why we're focusing on that. So that's why we're continuing to focus how to take those 23 minutes down to 10 minutes, because it means that if a customer is doing that at the level of 10,000 servers, they're ultimately saving 10,000 times 13 minutes, which is a lot of hours of waiting.
So here's a question about all the benefits that you talked about. Can you talk a little bit more about the type of expertise that is required for us to achieve these benefits?
Yeah, absolutely. So I alluded to that when I was talking about the diversity and the sheer dynamic range of expertise, right? In my slide, I talked about capacitors to cap theorem. There's huge, deep expertise in every part of the ecosystem, right? The tiniest capacitors to small algorithmic changes. And the good news is that much of that expertise is available in the community and can be leveraged, but it's absolutely critical that we have communication and collaboration across those expertise, or we won't be able to achieve the benefits. We won't be able to get the results. So individual of our customers don't need to have the expertise that they're leaning on us for. We don't need to have the expertise that we're depending on our software partners for, but everyone needs to bring expertise and quality execution, experience and diligent effort to their part of the problem. That's why I belabored that on our five pillars slides.
Okay, at the beginning of your presentation, you were talking about TCO. What are the key aspects of TCO that matter?
Right. So TCO, kind of total cost of ownership. The nice part about that, similar to time to get the hardware to running applications, is that it can be characterized as an all-in number, right? So dollars per terabyte per month, dollars per container per month, for example. The public clouds have done a great job of kind of bringing all that home into, if you will, a single number, right? The key factors, as we find it when we discuss it with our customers, of course, there's upfront kind of capital acquisition costs, the costs of the hardware. Then there is the operational investment in the day-to-day, the personnel of DevOps, et cetera. The more you're leaning on the machines, the more the integration has been done ahead of time, the less that is. So capital cost, operational personnel investment, operational electrons and basically electrons and exhaust as heat that needs to be dealt with. So a certain number of electrons need to be fed in, and then there's some secondary costs, real estate costs, maintenance, repair. Right, all of our racks are provided with a 3-year warranty by default, a 6-year warranty by extension, so that our customers don't have to worry about additional costs over time from physical replacement, and et cetera. So those are really the main dimensions: kind of capital costs of the equipment, operational costs of care and feeding the equipment, operational costs of personnel, both in terms of operations and in terms of development. All of those need to be considered when looking at the total cost footprint.
All right, and here's the last question we're going to take. How can we foster better participation between the open source software and open source hardware communities?
Yeah, this is a great question. So we did the OCP organization, we did our virtual summit a couple of weeks ago, and we had a number of discussions around software efforts, right, and relations between the hardware and the software. When I go to a Linux conference, there's also rooms, sub-sessions for hardware interactions. I think it's absolutely critical, most critical at the boundaries, right? So those folks that are working on infrastructure software that directly touches the hardware. But the more awareness that we can make of the kinds of decisions that are made, the kinds of scalability decisions, design decisions in the software layer, as well as in the hardware layer, we create that appreciation. Not that everyone needs to learn the deep aspects of capacitor expertise or consensus algorithms, but we need to have an appreciation. And we're trying to foster that in the overlap within the OCP community and also within the Linux community, within the Kubernetes community. Awareness is the most important thing. Awareness and collaboration. Who to ask, who to go to for questions.
Well, I know I promised that was our last question, but we did get another one from an anonymous attendee. Where have you seen market penetration for your hardware and solutions? Can you give examples of customers or markets that you've had success in?
Sure. So our high-level market targets are cloud service providers and enterprise SaaS companies. We have deployed systems with customers in the gaming space. A number of service providers that are ultimately providing cloud services, either public cloud types of services, bare metal types of services to their customers. We've also discussed with any number of companies that are hosting applications on behalf of their customers. So they're hosting clouds for genome processing, for example, or machine learning applications. And their customers are coming to these specialized service providers or specialized clouds for the same kind of scale out needs, as well as customers that are building it to support their own SaaS applications.
All right, thank you very much, Eric, and thank you all for joining us today. Just to reiterate Eric's call to action, we just ask that you check us out on our website. You can go there at www.sesame.com, and while you're there, you can check out some of our videos, one in particular called Sesame by IT Renew. If you would like to ask Eric some very specific questions to your situation, please contact him at Rydell@Work. So again, thank you very much for joining us.